Hey everyone, in the last lesson we were doing some envelope simulations. In this lesson I'd like to talk about how can we add some variations to our envelopes. And in the past lessons we were doing some variation by adding some attributes which allowed us to add some variations. But the drawback of the method was that we could only do it with the CPU engine, but not with the XPU. This time we would like to keep our XPU engine and still be able to add some variation to our envelopes. So let's see how can we do this. So um, here I have a few methods that might be useful to you. So the first method I would go with probably is this one. So here we have our envelopes, and I can play with the seed value. So we ended here in the last lesson, whereas the main simulation took place. So this time we're mainly focusing on the look of our envelope. So here I have my envelope, uh, some poly extrusion, UVs, quick shade, and just placing it starting from zero. Okay, and also uh, here I'm adding a p-scale attribute, so I could have some a proper size of my envelopes. And another thing that I've did here, that I've add some uh, difference to my position y-axis by using an ID attribute and multiplying it on a very low value. This way I am creating an illusion that my envelopes are not intersecting. If I turn this off, you see they are intersecting. So this way you can cheat. Okay, and here's the main um, randomizer happening. So here I have my envelope attribute being created, and I'm using this expression to add a variation, since I have three or four type of envelopes. I think three I have in this case, so I'm using uh, this number. If you have more variations of texture, so you will use the number that you have. Okay, so I'm using the ID attribute by randomizing the ID attribute and fitting it from 0 to 3, and also I'm adding this seed value where I can play with that. And then by using the envelope attribute, I'm extracting each type. So in this case 3, and I'm adding those textures. Okay, here's the result. So this way I can play with the seed value to get the result I'm looking for. Okay, so the second method, so here's the same p-scale attribute, the position y distribution to avoid intersection, some basic color, and sort attribute, so I could also play it. It works as a seed value in this case. So here, as you see, so here I have three type of envelopes, and I'm adding an envelope attribute to each of the envelopes. Okay, and in this for each cycle, in this case I'm using for each point. Okay, I'm copying one of the envelopes to the point randomly. Okay, so I'm using this envelope attribute, and by using the metadata, the iteration value that I'm randomizing this iteration value, and I'm multiplying it to 3, because I have those 3 type of envelopes, and I'm using this floor expression because in my case I have, if I have this envelope starting with 0. Okay, so it will use 0, 1, 2, so 3 type of envelopes, and this way it will randomly choose and copy one of the envelopes to our particle system. Okay, to each of the particles, and the same way I'm separating by using the envelope attribute, merging them all together, and by using this sort I can randomize my envelopes. Okay, and the last method where I'm creating this 3 points and sorting them randomly, and I'm creating this PTID attribute. The same system goes here as well, and it's almost the same as this one, but instead of ID attribute I'm using this PTID, and the same expression and the same procedure. Okay, and here I'm also having some random values. Okay, so yeah, this is what I'd like to share in this lesson. So this way you can add some variation to your geometry, and the rest is the same. I'm importing those envelopes separately and adding those textures separately. Okay, and the rest is the same, and now we have different envelope variations, but at the same time we are have our GPU render, which is faster. Yeah, this is about it. I hope you liked the lesson. If you find it useful, please subscribe, and I'll see you in the future lessons. Thank you very much, and goodbye.